Hi, everybody. This is test two review. So this is Cal 1 test 2 review. Okay, so let's take a look at problems. I'm not going to do all of these. By the way, the problems I'm doing are in your homework under test 2 review. So if you look at test 2 review, it's the same problems I'm doing. And if you notice here on these red numbers, the red numbers change. So you'll have a little bit different numbers than mine. This first one here, you have to know how to do this. I'm not going to actually do it, but this is find the derivative of the function by the limit process. So if you're not sure what the limit process is, I mean, we had it on the first test. That's why I'm not going to do it. We already did the limit process. The limit when x approaches, when the change of x approaches zero. So the limit process for taking the derivative is very similar. The change of x approaches zero. So take a look at that. You have to put x plus the change of x in there, then subtract it with the function with just x in it, all divided by the change of x. So make sure you know how to do that in the show your work. You definitely have to show your work. All right. Oh, and I need my formula sheet too that we're going to be needing. Let me get that. Oh, I have it right here. So don't forget, you're allowed your formula sheets that I provided for you in the modules. I think it was in like module 2 or something like that. The calculus derivative formula sheet. So let's just take the derivative of this number 3. It says use differentiation to take the derivative. The derivative of 8 is any derivative of any constant is 0. Look, I can't even read that already. There we go. The derivative of 8 is 0. So this is y prime, which means derivative. Derivative of 8 is 0. And then the derivative of 5 sine. If you go to your formula sheet, if you're not sure, one of them changed the sign, not sine, not the derivative of sine, but the derivative of cosine. But you need to use your formula sheet to know that the derivative of sine on my formula sheet is cosine. So it's 0 plus 5 cosine x. So that's my answer. 5 cosine x. This is the same thing. This is an x. Even though it says theta, just treat it like an x. People were missing that one because they didn't understand what it was telling them. Those are just variables. Okay, a silver dollar is dropped from the top of a building. Use the position function below for a free falling object. So here is the position function, the distance at any place. It says determine the position function. Well, initially you're on top of a building and you have a silver dollar and you're going to drop it. Initially, the silver dollar has a velocity of 0 because you haven't dropped it yet. And right before you drop it, initially it has a 0. Its height is 1359. That goes here. So my actual position function is 16t squared. Since initial velocity is 0, that all changes to 0. And your height is plus 1359. We get it here. That's how tall the building is. Now, to find the velocity function is taking the derivative of the position function. So the derivative of negative 16t squared, you bring the 2 in front and you get negative 32t. And the derivative of a constant is 0. So my answer for the velocity function is just negative 32t. And that's all. I'm going to leave it there now. Then they say, hey, plug 1 in or plug 2 into the velocity function and so on and so on. I don't think I'm too worried about the other questions here. Question 6, use the product rule. So I'll do one of these, and I'll do number 7 as a quotient rule. So the product rule, break out your formula sheet. You need to know the formula. By the way, you can actually multiply all this out and take the derivative straight and you'll be fine. But they're not always that easy. So just know how to use the product rule. The product rule says if you have two functions, and I'm calling this one f and this one g. If you have two functions that are multiplying together, f times g, what you do is take f then times g prime, the derivative of g, plus f prime times g. So do you see how one of the letters have a prime each time? So on the side over here, f is x squared plus 3. Do you see I put f on top of x squared plus 3? So f prime, the derivative of f, is 2x. G is x squared minus 8x. So the derivative of g, x prime, is 2x minus 8. And now we just plug it into the formula. So f is x squared plus 3. G prime is 2x minus 8. Plus f prime, which is 2x. And g, which is x squared minus 8x. Then we're going to multiply these together. Oh, Lord, you FOIL that, and I get 2x3 minus 8x squared plus 6x minus 24. Here, I'm going to distribute also, which equals a plus 2x3 minus 16x squared. And then we're going to combine like terms. 2x3 and 2x3 is 4x3. A minus 8x squared and a minus 16x squared is a minus 24x squared. 6x plus 6x, and then a minus 24. And that's what I get for number 6. I should verify that I'm getting these correct. That's what they get. They just factor a 2 out of the end. I mean, if the test is multiple choice, they factor a 2 out of the end. And if it's not multiple choice, then I would accept this answer. Let me see. I do see something wrong. For some reason, seems like I added, there's an extra 2 in here somewhere. Let's see where I messed up. 2x. Oh, right here. Where did I read? No. My numbers are different from on here also. That's funny. I didn't print out the same one that I'm working on. Okay, so that's the product rule. That is the product rule. So now we're going to do the quotient rule. Quotient means divide. The top is f, the bottom is g. Now you can do this problem once again without using the quotient rule, but I'm going to use the quotient rule just to show you it. So if f is 7x to the 3 over 2, then f prime, you bring the 3 over 2, is 21 over 2, x to the 1/2. 3 over 2 minus 1 is 1/2. Right? 3 over 2, bring it here. 3 over 2 times 7 is 21 over 2. Now, g would just be x, the bottom, and g prime, the derivative of x, is just 1. So going to the quotient rule on our formula sheet, quotient rule says Here's the quotient rule. If I have f divided by g, I get f prime g minus f g prime, all divided by g squared. So I'm going to start off with f prime 21 over 2 x to the 1/2. G is just times x, minus f 7x to the 3 over 2 times g prime, which is 1. Okay, so this 2, 1/2, and there's an invisible 1 here, is 21 over 2 x. When you multiply two numbers with the same base, you add their powers. 1/2 plus 1 is 3 over 2. Minus 7x 3 over 2. Ah, interesting. 21 over 2 minus 7. 21 over 2 minus 14 over 2. I just changed the 7 to 14 over 2. They're the same thing. 21 minus 14 is 7. So my answer there is 7x over 3 over 2. And then we do need to do the bottom. The bottom is g squared. G is x. The bottom is g squared. G, and then we square it, x squared. We're still not done. This is 3 over 2, we said. 3 over 2 minus 2. That 3 over 2 is 1/2. Minus 2, since we have x's on both, equals 7 and a negative 1/2. X to the 1/2, negative 1/2 power. It can be written like this, or it can be written 7 over x to the 1/2 power. Either one of these is fine. So that's the quotient rule. Hopefully everybody's been practicing. I haven't gone into the homework and verified how many people are doing homework and are not. But next week I will be updating the homework grade. Alrighty. Find the derivative of this transcendental function. Just as there's the sign. If you look, you have to use the product rule. There's f and there's g. The product rule says if you have f times g multiplied together, look at the product rule. It says f prime g plus f g prime. And I think I wrote it backwards last time. Just as long as one has the f and the other one has, and one has an f, the other one has the f prime. One has g, the other one has g prime. And as long as there's one prime in each. So if f is t to the 4th, f prime is 4t to the 3rd. If g is the sine of t, g prime is the cosine of t. And then you just plug everything into the formula. That's it. The second derivative is just taking the derivative twice. So the second derivative, bring the 3/2 in front. 3/2 times 2 is x to the, wait, I'm going to erase everything here for a second. So bring the 3/2 in the front. So 2 times 3/2, if you notice the 2's cancel, and you're left with 3x. And then you subtract 1, which is 2 over 2. 3 over 2 minus 2 over 2 is 1 over 2. So that's the first derivative right there. That's the first derivative. The second derivative, you bring the 1/2 times 3, and you get 3 over 2x. And then you subtract 1. 1/2 minus 1 is a negative 1/2. And there's what our answer would look like. That's 3 over 2. It's kind of hard to see. All right. So let's do, I don't have number 10 circled to do it, but I need to do, wait, maybe I do. Let's see. I have them marked over here. Yeah, I have number 10 and 11. 10 and 11 both use the chain rule. That's usually where a lot of people miss their questions. They're, from the chain rule. This is the same thing as saying 7 tangent u. So g is 7 tangent u. In other words, I'm changing u to 9x. The tangent rule, we want to make it simple. So having a 9x in the tangent doesn't make it simple. So I'm changing u to 9x. The derivative of 9x is just 9. So I'm going to my formula sheet now and see where it says the tangent of x. The tangent of x. So if you look at the formula sheet, it says the derivative with respect to x of the tangent of x changes to the secant square of x. So this is 7 secant squared of u, because we're taking the tangent of u. And then you have to put u prime because it's the chain rule. U prime is 9. We got it from up here. So the only thing left in this problem was plugging u back into the formula, 7 secant square of 9x plus 9. And there's our answer. Wait, it's not plus 9. I'm looking at plus 9. I'm saying there's no plus in this. It's times u prime. So that's a times 9. So the last step is 9 times 7. 63 secant squared of 9x. There we go. So there's no plus in there. I don't know. I put a dot there and I thought it was a plus. I couldn't read my own writing. Number 11, you can use the chain rule also. Try to simplify it and make it a little bit easier. I'm going to change it to y equals e to the u. And u is negative x to the 5. So the derivative of u is negative 5x to the 4th. Negative 5x to the 4th. So if you look at the derivative of e to the x or e to the u, the derivative, finding the derivative of e to the u, it's just e to the u. But then since we're using the chain rule and u could be more than just an x, then we do u prime. So the answer is e to the u, which is negative x to the 5th, times y prime, which is a negative 5x to the 5. And normally you put that in front, negative 5x to the 5, e to the negative x to the 5th. And that's what the problem would look like. Number 12, there's no log, but there is a natural log. Let me find, I think I wrote down an example of a natural log somewhere. Where did I do with that? I'll just do one problem. There's a couple of them I wanted to do. How's this? Here, let me just write an example. What's the derivative with respect to x of the natural log of 3x? So we're going to simplify that and make it the natural log of 3, or just to make the natural log of u. And u is 3x. Using the chain rule, so the derivative of u is just 3. And so on your formula sheet, look up the natural log of u. What's the derivative of ln u? And the answer is the derivative is 1 over u, and then there's a u prime here. 1 over u is 3x, and the derivative of u is 3. So my final answer, oh wait, my final answer is 3 over 3x. And that just means the 3's cancel. So my answer is 1 over x. Okay, let's see the next page. Implicit differentiation. So if you look here, there's some steps in the book for implicit differentiation. And I think I might have did a help video on it. We're going to take the derivative with respect to x. So this, we want to find y prime, the derivative of y. So we want to find y prime. We're taking the derivative with respect to x. So using implicit differentiation, take the derivative of 7x squared and I get 14x. Take the derivative of a negative 4y squared and we bring the 2 in front and I get a negative 8y because 2 minus 1 is just 1. However, since we're taking the derivative with respect to x and we're dealing with a y, we also have to add in a y prime there. And then the derivative of 16 is 0. We want to isolate all the y's on one side. I'm going to take this 14x to the other side, minus 14x minus 14x. And I'm left with negative 8y, y prime equals a negative 14x. And I want to take this to the other side. It's multiplying times the y prime, so I'm going to divide it. Divide this side by 8, negative 8y. Divide this side by negative 8y. And I get y prime equals 14 over 8xy. And you can reduce that if you want, 7 over 4xy. My 4's and y's look the same. I think that's all they wanted us to do. Yeah, that's it. They didn't tell us to plug nothing in with it. Alrighty. Okay, so here's one. Find the slope of the tangent line to the graph at the given point. So we want to find this slope, this slope right here. What's the slope of that line at that point? We need to take the derivative of this. So we're going to use implicit differentiation. I'm not going to actually do this because it's just a little time consuming. I only have a little bit of time left. But here you have to use the product rule to take the derivative of this. And don't forget, when you take derivative of y squared 2y, then you have to add in a y prime because you're taking the derivative with respect to x. And then there's an equal sign, and then just take the derivative of this side. So this side you use the product rule. This side you just take the derivative, set everything to y prime. That once you have y prime by itself, you just plug this in to x and this into y, whatever your x's and y's equal, and that'll give you your slope. Whatever your answer is now, that'll give you your slope. Slope is y prime. They both mean the same thing. Okay. Okay, this problem is definitely on the test. So you better know how to do it. And I'm only looking for the answer to part A, so there's a part B and a part C that's not on the test. I'm only looking for the answer to part A. So A, B, these three are the same. They just have different distance. So this is how you do this problem. And it takes a little while. You have this rectangle. You have this triangle. The ladder is 25 feet long. This is the ladder. The ladder is 25 feet long. The base of the ladder is pulled away at a rate of 2 feet per second. This bottom of the ladder is pulled this way at 2 feet per second. What is the velocity of the ladder when the base is given below? So we want to know what is the velocity of the top of the ladder. We're trying to find this velocity. And if I call that the y-axis, that velocity is y prime. By the way, this 2 feet per second that I said the base is, that's x prime. The velocity is the derivative of the position vector. So that's x prime. So we're trying to find y prime. I call it x prime because this is the x-axis. And so it says the base of the ladder is 15 feet away from the house. Before we begin, we have to find how high the ladder is up above. And you can use Pythagorean theorem. X squared plus 15 squared equals 25 squared. So x squared plus 225 equals 625. X squared equals 400. And x equals 20, right? 20 times 20 is 400. So this x is 20. So now we need a formula to take the derivative of x squared plus y squared equals 25 squared. So let's take the derivative of x squared and by the way, this is all, if you go to the rate section, this section where it's just, it tells you all these little word problems that we had, you're taking the derivative with respect to time. So you're taking the derivative with respect to time. Since t is different letter than x and y, you have to add in the x prime and the y prime. So the derivative of x squared is 2x with an x prime. The derivative of y squared is 2y with a y prime. And the derivative of 25 squared, 625, is 0. Any constant is 0. We know everything. The only thing we're trying to find is y prime. So I need to take this to the other side by subtracting. I'll have negative 2x, x prime over here. Then I'm going to divide by 2y. And I get y prime. Do you see? I take that over, then I divide by 2y. And this is what I get. Do you see? Here's my x. This is y. X and y. This is x prime. Everything fits in. Now all you have to do is fit everything in and you have your answer. You have the velocity. There's my y. Well, what did I say? It was 20. Y is 20. X is 15. Plug x15 here. Y20 down here. And then don't forget your x prime was 2. And that gives you your y prime. That gives you the velocity of the top of the ladder. Here, they just want you to take the derivative with respect to t also. The same thing we just did. Okay, so you're going to have to write this formula down. Hopefully, maybe I should put it on the test. It says the radius of a sphere is increasing at a rate of 5 inches per minute. So first of all, the formula for a sphere, the radius of a sphere is increasing at a rate, find the change of rate of the volume. The volume of a sphere is 4/3 pi r to the third. So you have to know this formula. And it says the radius of a sphere is increasing at a rate of 5. That's r prime. You know, when we're talking about increasing its rate, that's r prime. So r prime equals 5 here. R equals 10. Find the rate of change of the volume. So the rate of change, once again, rate of change, that's what we did here, increasing the rate. That was r prime. But the rate a change of the volume is V prime, the rate of change of volume. That's what we're looking for. Find the rate of change of the volume. So let's take the derivative of this with respect to time. The derivative of V is 1, but you need a V prime. Here, you bring the 3 in front. 3 times 4 is 12. 12 divided by 3 is 4. You get 4 pi, and then subtract 1 r squared. So, and don't forget, you also need an r prime after you take that derivative with respect to t. So we're looking for v prime, 4 times pi. R, we already said r was 10, 10 squared, and r prime, we said, was 5. And there's your rate of change. Just multiply all that together. Number 19, we won't have Newton's method on the test, so don't worry about number 19. Well, that is, I only did 30 minutes. I thought I did a lot longer. But that is pretty much the test review. If you look at, I think that's the test review. Let me see if that was, yeah, that was it. That is the test review. Just know how to use the different rules in here. Oh, wait, there was a couple of more I wanted to do. Give me a second. Don't leave. So there is a couple more I wanted to look at. Let me find some paper. How do I add I don't even think it'll let me add a blank piece of paper in here. You would think it would. Oh, there's the default. Okay, so I think there's one or two more. Let's find the derivative. Let's find the derivative of arc cosecant 5x. Is that what I wanted? I'm not even sure. Okay, I'm glad I picked that. Because there's a couple that are not on the formula sheet. Arc cosecant is not on the formula sheet. But it's in the book. So when you do the homework, that is in the book. Give me a second. Let me hit. Okay, so arc cosecant, I found the formula. It's in the book. There are 3. Write the ones that are not on here. I mean, we have arc tangent, we have arc cosine, we have arc sine. Do their inverses. So arc cosecant. If you look, by the way, this arc secant, cosecant, this is the same thing as cosecant -1 5x. These mean the same thing. That's what arc means, the inverse of it. So arc cosecant, the formula, I'm going to put it up here. Cosecant -1x changes to -1 x times the square root of x squared minus 1. So that's the formula that you should be using. But we're going to take the cosecant, arc cosecant of u. So when you do this formula, there will be a times u prime. I mean, if you look it up, the u prime will be on top then. So there is a u prime in here. So u ends up being 5x from here. So just know u prime then will be 5. So I'm going to plug it straight. Now you plug everything straight in the formula. -1 times u prime. U prime is 5. All divided by x. By the way, x is just the u when we're talking about that u part. So u is 5x, square root of u squared, which is 5x squared, minus 1. That's the answer. We just have to simplify it a little bit. 5x square root of 25 x squared minus 1. And that's the derivative of the inverse of cosecant, arc cosecant. So, I mean, you just plug it in the formula. We're using the chain rule, but you're just plugging it into the formula. And let me see if there was any more. I think that's just about it. I don't see any more that I wrote down. We did the derivative of the natural log of something. Yeah, no, I think we're done. Use your formula sheet. Make sure, when you're allowed one page of notes and these formula sheets I provided. So make sure you're using these when you're doing the homework. Because if you're not using these, except for the test, then you're going to be looking around and might not understand what this says. If you have any questions, feel free to call me.